Hey there, here's another example of a factorised quadratic, fully factorised, and this is how you sketch it. So step one, remember, is that you are going to find the y-intercept. So that is the point where x equals 0, so we put x equals 0 into the equation to find y. So y, I'm just going to write the full equation down. This is how you would correctly do it. Then put zeros in for the x's. Okay, so that would be -1 times -9. So 9 is your y when x is 0. So one of your points now is going to be 0, 9. Step 2 is you find the x-intercepts. Sometimes this is called and I notice it's plural because there's two solutions to when y equals 0. So y is, we're going to set it to equal 0. So the equation x minus 1, x take 9 equals 0, which means that either x take 1 is 0 or x take 9 is 0. So we're going to solve each one. X is either equal to +1 or x equals 9. So we write down those coordinate points. 1, this one here, x of 1, y of 0. Write it down so you can plot it easily. The second one is 9 and 0. Notice it's different to this y-intercept where 0 comes first and then 9. So point to be made here, the x-intercepts, are sometimes called the solutions, because it's the solutions to solving the quadratic equation, the stuff that we've been doing over and over, okay? Sometimes it's called the solutions, and sometimes it's called the roots. I haven't noticed that a lot in Australia or in the Australian curriculum, but there is another way of talking about the x-intercepts, finding the roots or the solutions of the equation. Okay, step 3 is the axis of symmetry and turning point. So that's the center. The axis of symmetry is the center or the center line of the graph. Axis of symmetry. Once we find that, we find the turning point. 1 point. Okay, so we're going to go halfway between the solutions or the roots, remember. So that's halfway between 1 and 9. Okay, so that's going to be 5, so there's a distance there of 8. Okay, 9 take 1 is 8. Halfway is going to be 4, is half the distance. So we can just go 1 plus 4 is 5. So that's the point where the x equals 5. So that would be halfway between 1 and 9. Take this guy and put him into the equation. The equation of x, just going to write the equation fully down, x minus 9. We know the x is 5. Okay, so 5 take 1 is 4, multiplied by -4 is -16. So that central point, turning point, is 5 and 16. That one, these two, and this one. So I have 4 points now, and the thing I have left to do is do a sketch. So out to here, I'm going to draw my Cartesian plane, or my graph. I'm going to sketch. So it's okay in senior mathematics to do a sketch like this on a white paper, as long as all the features are really clear. Otherwise, you use your grid paper, your quad books, and you do a very exact graph. But this is how a sketch would be very acceptable, just saying. Okay, first point is at 0 and 9 up here. That's the y-intercept. I'm going to label it. The x-intercepts are these guys here, so at 1, 0 and 9, 0. Okay, it's not to scale, but now I've got a little bit of a scale for my x-axis, 1 and 9. The turning point and axis of symmetry, I'm going to put in the axis of symmetry first, which we said was at 5. There's the equation of that line. That vertical line is x equals 5. And then I'm going to put in the actual turning point, back to my black pen, 5 and 16. My bad, negative 16. Dull. Okay. I'm going to extend this axis down because I've put 9 up here, so I need to put negative 16 a little bit proportionately down here. Okay, I've got my 4 points there, and I can just put a smooth curve all through them. So a little bit wonky, but I'm respecting the points. I'm respecting these guys. I'm respecting this one that I've labeled, and I'm respecting this one here. I've shown all the features. I have my axis of symmetry in here. And the last thing I have left to do is to label that graph. So that's the graph of y equals x minus 1, x take 9. Done deal.